we now discuss the solution of a problem from the section Coordinate Geometry. It is a question based on the concepts of a circle, a parabola, and an ellipse. This question has appeared in the Joint Entrance Examination Main held on 26th June 2022 in the first session. The given question is, let the common tangents to the curves 4 times x square plus y square is equal to 9 and y square is equal to 4x intersect at the point Q. Let an ellipse centered at the origin O has lengths of semi-minor and semi-major axes equal to OQ and 6 respectively. If E and L respectively denote the eccentricity and the length of lattice rectum of this ellipse, then L by E square is equal to. We are given a circle 4 times x square plus y square is equal to 9 and a parabola y square is equal to 4x. And the common tangents are taken and it is given that they intersect at the point Q. And there is an ellipse which is centered at the origin O, and that ellipse has lengths of semi-minor and semi-major axes respectively equal to OQ and 6. If E and L respectively denote eccentricity and the length of the lattice rectum of the above ellipse, then required to find L by E square is equal to. We now discuss the solution of the problem in detail. We have a circle C, x square plus y square is equal to r square is equal to 3 by 2 whole square. It's actually 4 times x square plus y square is equal to 9. That we have written as x square plus y square is equal to 3 by 2 whole square, that is r square. So the radius of this circle is 3 by 2. And we have a parabola P, y square is equal to 4x, written in the standard form 4ax is equal to 4x, then a is equal to 1. So therefore, the radius of the above circle is 3 by 2 and a of this parabola is 1. Agreed. Now, we have the circle x square plus y square is equal to 3 by 2 square, a circle center at the origin and a radius 3 by 2. And a parabola y square is equal to 4x, opening rightwards, and for that a is 1. Agreed. Now, the equation of the tangent to the circle in the slope form is given by y is equal to mx plus r minus r, the radius, times under the square root of 1 plus m square. In our case, the radius is 3 by 2. Therefore, the equation of the tangent to the circle C in the slope form is equal to y is equal to mx plus r minus 3 by 2 under the square root of 1 plus m square. The equation of the tangent to the parabola in the slope form is given by y is equal to mx plus a by m, where a is 1. Therefore, in the slope form, the tangent to P is y is equal to mx plus 1 by m. And look at these tangents. y is equal to mx plus or minus 3 by 2 under the square root of 1 plus m square. Y is equal to mx plus 1 by m. And it is given that these are the common tangents. To be common tangents, we must have mx plus 1 by m is equal to mx plus or minus 3 by 2 under the square root of 1 plus m square. Now, squaring and cross multiplying, we get 9m square into 1 plus m square is equal to 4. And we get a biquadratic equation, that means an equation of degree 4. And we have factorized, and the factors we have found as 3m square minus 1 into 3m square plus 4. And equating 3m square minus 1 is equal to 0, we get 3m square is equal to 1 and m is equal to plus or minus 1 by root 3. We have not considered the other factor 3m square plus 4 because it is 3m square plus 4 will not contribute any solution for m, because 3m square plus 4 is never 0 for any value of m. Therefore, you can reject that factor. Thus, the common tangents are y is equal to 1 by root 3x plus root 3 and y is equal to minus 1 by root 3x minus root 3. We continue in the next slide. The common tangents are here, and it is given that this common tangent intersect at the point Q. So these two equations we take and solve for x. From that we get the value of y. Thus we get the point of intersection of these two tangents. That now 1 by root 3x plus root 3, that of the first tangent, is equal to minus 1 by root 3x minus root 3. Now simplifying, we get 2 by root 3x is equal to minus 2 by root 2 into root 3, 2 cancels, and thus x will be equal to minus 3. When x is minus 3, substitute in the one of the tangents. When x is minus 3, y will be 0. Y will be 0. So that means the coordinates of the point Q are minus 3 comma 0. You note down that this point Q lies on x-axis because the y coordinate is 0. Agreed. So here is the diagram. The two tangents, common tangents, they are intersecting at minus 3 comma 0, and that's on the x-axis. Agreed. We continue in the next slide. So thus we have seen the coordinates of Q are minus 3 comma 0. We have already noted down that Q lies on the x-axis. Now we are given an ellipse E with the center at the origin and with the semi-minor axis equal to OQ. That is, this is O, this is Q. This is the semi-minor axis, and the semi-major axis of that ellipse is 6. So if this is semi-minor, so the y-axis must be the semi-major axis. That means semi-major axis will be along the y-axis, and it will be 6 units. And the origin O of the center E, so the center of this ellipse is the origin, and the semi-minor axis is along x-axis. Therefore, the semi-major axis must be along y-axis. And the lengths are the length of semi-minor axis is OQ. The length of the semi-major axis is 6. So, the equation of the ellipse is such an ellipse: x square by OQ square plus y square by 6 square is equal to 1. So this is the ellipse. This is the ellipse. OQ is the semi-minor axis, and semi-major axis is along the y-axis, and it is 6 units. This will imply x square by 3 square plus y square by 6 square is equal to 1. It is of the form x square by a square plus y square by b square is equal to 1. You note down that a less than b, that is the semi-minor axis is less than the semi-major axis, a less than b. Normally in a standard form, a will be greater than b, and the formulas that you remember are for a greater than b. But here it is a less than b, be careful, and the length of the latus rectum of this given ellipse is L, that is equal to 2a square by b, because a less than b. But what you remember is 2b square by a, that is for a greater than b, but now it is a less than b, it is 2a square by b. Substitute the value of a 3, so 2 into 3 square by b is 6, and when simplified you will get 3. And the length of the eccentricity, that is e square, is equal to 1 minus a square by b square. You remember it is a less than b, that is why it is minus a square by b square. So that is equal to 1 minus a square, that is 3 square, by b square, that is 6 square, that is 1 minus 1 by 4, that is equal to 3 by 4. This is e square, that is eccentricity square. Required to find L by e square, that is equal to L is 3 by e square is 3 by 4. After cancellation, we will get 4. Thus, the answer for this question, that is L by e square, is 4. That is the detailed discussion of the solution of a problem from the section coordinate geometry. The beauty of this question is the circle, parabola, ellipse, all the three concepts are coming together in a problem. It is not a very difficult question, and it is definitely takes little bit of time, but it is an interesting question. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.